Hello, and welcome back to our discussion of ANOVA. In our last lecture, we looked at experimental error and how experimental error can increase when we have a larger number of particular populations. Today, we're going to talk about the experimental design and ultimately a completely randomized design and how we would create it. Now, in our experimental design, one of the things we need to look at is creating a good experimental design. And this good experimental design is going to include replication. We'd like to replicate all of what are called our experimental units. These are the items that we have our treatments applied to. Our randomization. We need to randomize. Randomization is a statistician's best friend. Randomization allows chance to dictate which treatments are assigned to which experimental units. And we need the ability to apply this treatment. There are three phases to our experimental design. The first phase involves stating the problem. Without the problem, we can't do any design. The next phase involves designing the experiment. What type of an experiment do we wish to design? Now, for the case of this video, we're only going to be looking at designing a completely randomized design. And then we need to collect and process the data. So let's get into our discussion on completely randomized designs. These are the easiest experimental design. In a completely randomized design, we randomly assign the order of our experimental units. However, once we've randomly assigned our order of experimental units, we also want to randomly assign the treatments to these experimental units. Now, what would this mean? Well, suppose we have 16 seeds, and we want to measure how some type of a fertilizer, let's say something with 10% nitrogen, 15% nitrogen, 5% nitrogen, and no nitrogen, are going to impact the growth and the yield of our particular plant. Well, given we have 16 seeds, we'd like to number these from 1 to 16 and then create a randomization of these seeds. Now, this can be done using drawing numbers from a hat. This can be done using a table of random digits that can be found pretty much anywhere on the internet. Or it can be done using a computer program such as R. Now, once we have randomly assigned our particular seeds, these are our experimental units, by the way, then we can randomly assign these 4 treatments to be applied to the seeds. And in that way, we allow chance to determine which seed gets assigned which treatment. So, how might this be done in R? Well, let's take a look. Now, what I'm doing is just creating the design that we just discussed. So I'm going to let X just be a sequence from 1 to 16, and what this is going to do is just create numbers from 1 to 16, as you can see right here. I'm also going to obtain my treatments, and we're just going to call these treatments A, B, C, and D, and they're going to be 4 treatments each, for a total of 4 treatments for A, 4 treatments for B, 4 treatments for C, 4 treatments for D, and this will match up with our 16 experimental units. Now, I need to sample the treatments, but the way that these are set up right now, I need to do a little bit of data manipulation, and I'm going to turn this into a matrix. And then, as we'll be able to see, Y is now A, B, 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 C, 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 D, 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 D. I now want to sample Y, and when I do so, I'll make this a data frame. By creating this data frame, I now have removed those quotation marks. And notice I've got C, 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 B, C, A, D, A, B, A, D, B, B, A, D, D as how my treatments are going to lay out. But now I need to sample X. These are my seeds. And so when I sample X, instead of getting the values 1 through 16, notice I get 6, 16, 10, 1, 14, 15, 13, 9, 5, 7, 4, 12, 2, 8, 11, and 3. And so now I want to assign my treatments to my experimental units, which is what I'm going to do when I run this line of code. And so now, as we can see, seed 6 gets treatment C, seed 16 gets treatment C, seed 10 gets treatment C, seed 1 gets treatment B, seed 14 gets treatment C, etc., etc. So we have randomly assigned our seeds, and we've randomly assigned the treatments to the seeds, thus creating a completely randomized design. Now in our next video, we'll start looking at how we can analyze the data. We've got to collect our data and we've got to analyze it. That's the last phase of our experimental design. So, see you then.